Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 7B assignment. First one we're going to take a look at here is 2. Find and correct the 3 significant figures of the unknown lengths. Okay, so we have this angle. From this angle, we want to figure out which 2 sides these are. This is the side across from the right angle, so this is the hypotenuse. And this is the side across from the angle, so this is the opposite. Right? So our dear friend SOHCAHTOA here tells us that if we have opposite and hypotenuse, that's going to be sine. So I want to do sine of 61 degrees equals opposite, which is x, over hypotenuse, which is 8. Okay? I would highly suggest when you're doing this, like this side we don't know or we don't want to know, so don't label that one, because then it makes it really easy, because then you just look at the 2 letters that you have, opposite and hypotenuse, and find out which one of these 3 trig functions deals with that. Okay? So then what we want to do here is we want to get x by itself, so if x is on the top and the constant is on the bottom, just simply multiply both sides by 8, and that will tell us what this x side is here. So we will do, let's see, clear that out, and we will just do 8 times sine of 61, or just 8 sine 61, and we get 6.996. So basically 7.0. Oh, sorry, it says the 3 significant figures. So let's look. First significant figure, 6.996. It is going to be 7.00 to 3 significant figures, and that's centimeters. Okay? For C, here's our angle. The side that we want to know is opposite. This is the hypotenuse, but we don't want to know the hypotenuse, and we don't know the hypotenuse, so I'm not going to label it. And so that by default means that this here has to be the adjacent. So opposite and adjacent is tangent. So I would set up tangent 69 equals opposite, which is x, over adjacent, which is 3. Okay? So then, again, since our variable's on top and our constant's on the bottom, we multiply both sides by whatever that constant in the denominator is, and that goes away, and we get that x equals 3 times tangent of 69. 3 tangent 69 gives us 7, and this is the 3 significant figures, 1, 2, 3, so 7.82. And that's going to be centimeters for x on this one. Okay? If you're going through and you're entering this into your calculator and you're getting totally different answers, that's probably because you are in radians mode. So make sure that you're in degrees when you're doing these. Okay? Okay. All right. F here. So this here is the hypotenuse, because it's across from the right angle. And this is next to, so this is adjacent. So hypotenuse and adjacent is cosine. So we would do cosine 71 equals adjacent, which is 7, over hypotenuse, which is x. Okay? So now this is a little different because we've got the variables in the denominator. So there's a couple ways to do this. I'm going to show you the long way, and then I'm going to show you a shortcut. So first thing I'm going to do is I don't want that denominator anywhere, so I'm going to multiply both sides by x. So I get x cosine 71 equals 7, right? And then I want to get x by itself, so now I divide both sides by cosine 71. Cosine 71, so I get x is going to equal 7 divided by cosine 71. Okay? Now, another way that you could have done, the way that I like to do this, is I know that if I start with cosine 71 equals 7 over x, if you'll notice, this 7 stayed here. This 7 stayed here the whole time. Okay, so that 7 stays here, and the x and the cosine 71, if you'll notice, those just switch spots. So I know that if I get my variable in the denominator, I'm going to switch it with whatever's over on this other side. So I'm going to say, oh, now this x is coming over here, 7 stays there, and then I'm going to put cosine 71 over there, which is the same thing as this. Okay, so that's just a quicker way to do that once you've done that a few times. Okay, so we're going to do 7 divide by cosine of 71, and we get 21.50 for 3 significant digits. So x, let's go back to blue, x equals 21.5, and that is centimeters. Okay? Okay. Moving on to the next one, number 3, considering the triangle alongside, find x. Okay, so we've got this angle, we want that side which is opposite, and we have this side which is adjacent. Okay, so for part A, let's see, opposite and adjacent is tangent. So I know I'm going to do tangent of the angle, which is 53, is going to equal opposite, which is x, over adjacent, which is 3. Multiply both sides by 3 after I leave myself enough room. So we do that, and we get that x equals 3 times tangent of 53. 3 tan 53, and that gives us 3.98. Does it say word around? Doesn't say word around, so let's just do 3 significant figures. 3.98. So x equals 3.98 meters for part A. Okay, for part B, find y using Pythagoras' theorem. So that's our a squared plus b squared equals c squared, right? So the c is the part that we don't know, so we'll just leave that as y squared. A we know is 3 squared, and then we can call this b, which we just figured out is 3.98 squared, right? So if we do that, we can do 3 squared is 9, and that's basically 4 squared. Let's just call that 4, just to make our life easy. So this is 3 squared is 9, 3.98, 4 squared is 16, equals y squared. So that's 25 equals y squared. So we square root both sides, and we get y equals plus or minus 5. Obviously, it's not going to be minus 5 because it's a length of something. So we get rid of the minus 5, and so we get y equals 5 for that. Okay. Now we can also do this using trigonometry. So this was part I. So if we do this using trig, we could say, oh wait, this is the hypotenuse. We don't want that anymore. So adjacent and hypotenuse is cosine. So we can do cosine 53 equals 3 over y, right? Since our variable's in the denominator, we can just swap it with whatever's on the other side. So we get y equals 3 divided by cosine 53, and see what we get there. So 3 divided by cosine 53, and we get 4.98 meters, which is essentially, and this is meters, which is essentially y equals about 5 meters. Okay. Okay, one last one is number 6. Use the information in the diagram to find the length A to C. So we want to find A to C. So let's do this. We don't have enough info to find out what AC is right off the bat, but what we can do is we could find this here. Oh, no, wait. Yeah, we do. We can figure out what AC is. Sorry. Because look, we've got this side is the adjacent, and this side is the hypotenuse of this triangle ACD, right? So adjacent and hypotenuse is cosine, so we could say cosine of 31 equals 5 over h for hypotenuse. The variable's in the denominator, so we switch with whatever's on the other side. So h equals 5 over cosine 31. So 5 divided by cosine of 31 gives us 5.83, we'll call it. Okay, so this is 5.83. and officially centimeters, and then find the length of A to B. So that actually kind of helps out, because since we have this side here and that side there, we can actually find this other side using good old a squared plus b squared equals c squared, right? A squared plus b squared equals c squared, because we got a right triangle in here. So the important part here is that 5.83 is our c squared. And then the other one we can say is 4 squared plus this AB, we'll call that x squared. So 16 plus x squared equals whatever, 5.83. You know what? That's already in there. I'm just going to do squared. And it's not even a rounded answer. 34.0, we'll call that. 34.0. Subtract 16 from both sides. And we get x squared equals, let's see, we got to borrow one from there, right? 18. Oops, just write that a little lower. Equals 18. So we square root both sides, and that will tell us what our x is. So we do second square root of 18, and we get 4.24. And that is centimeters. Right? Okay, that's all we have for the 7B assignment. If you have any further questions on any of this, please feel free to ask. Thanks.